For the first few minutes, we can pair up on this exercise. So again, the exercise is that ransomware has taken over Jay's computer. There is a ransomware section of the Kazakhstan Central Headquarters website. I can Slack you the link directly to that. Once I get my bearings straight. And so maybe Risa, do you want to pair with Cassie? And Krista and Christelle, you can work together. So Sam and Shane and Robert and Evelyn work together. Is that cool? And Cassandra and Kim. You're with Cassandra, yeah. So these are hard exercises. These are tricky. So 2 heads are better than 1. And we'll spend just a few minutes on it, and then I'll demo. Okay, let's get started. So until now, for the vast majority of everything we've been doing, we have been working with numbers primarily, right? As much as I keep on trying to claim that programming is not related to math, it seems like everything we do is numbers. That being said, we are now going to move along to some other things, although we're not going to leave numbers high and dry. We actually alluded to this before, the concept of a string, which is basically working with words and letters and characters. So as you know, to print, let's say, the number 2, I say P2, and that prints the 2 to the screen. If I wanted to print a word, let's say hello, what I do is I would have to take the word hello in quotes and print that. What happens if I don't use the quotation marks?
You'll get an error.
I'll get an error because Ruby will say, error on line 1, undefined local variable or method hello. I have no idea what hello is. But if you do put the hello inside quotation marks, then Ruby recognizes that whatever is in the quotation marks is what is called a string. A string is a valid piece of information. Just like a number is a valid piece of information, so too a string is a valid piece of information. Now, if I wanted to write a program that printed out some words that didn't actually include the quotation marks, because that's sort of weird. Let's say I wanted to say, welcome to my program. It would be nice to write that without the quotation marks, even though in my code I had to use quotation marks to indicate that it's a string. To do that, Ruby actually comes with another type of printing keyword called puts, or just to call it puts. And that will print the string to your terminal. However, it will omit the quotes when it actually prints it. So that's a prettier way to print a string in a program. Any questions about that? Straightforward? Okay.
Does it have to be just single double quotes, or can it be single quotes?
Great question. So Kay wants to know, I use double quotes, can it be single quotes? And the answer is it can be single quotes, although we'll see shortly there is a slight difference between when you use double quotes and single quotes, but just one slight subtle difference. But yes, you could use single quotes. However, you must make sure to use the same thing on both sides, right? What happens, let's say let me just lop off. Let me just put one single quotes on the beginning and nothing at the end. What do you think will happen? I get an error message. However, the error message that I get is quite not clear. It doesn't say, hey, you're missing the end of your string, you're missing a quotation mark. It says unterminated string meets end of file, which is a very fancy way of saying that your string keeps on going and it doesn't end. And we reach the end of the file without seeing the termination, the ending of your string. Does that make sense? That's how you read that error message. Now that will happen even in this situation where I start the string off with the single quotes and end it with the double quotes. That still causes the same problem because Ruby is still looking for the end of my string that started with the single quotes and never found the closing part of, never found the reciprocal single quotes to close that string. Does that make sense? That is an error you'll get a lot because it's very easy to forget the end of a string, the end of the quotes. Or it's easy to mismatch quotes. Okay, however, pretty much for the duration of this, I will usually demo with double quotes. Again, you'll see why in a bit. Okay, let's do this. What happens? What do you think will happen when I run this? Catfish is a reasonable guess. So you can actually quote unquote add strings together this way. The official term for that is concatenation. Coincidence to the fact that there's a cat in there. If I did dogfish, that's also concatenation. But you can call it adding strings. Now what happens if I do this? It's a good guess, but I actually get an error. Ruby does not let you subtract a string from another string. It could have, but that's another example of how we see programming languages often can be arbitrary. The designers of Ruby decided, yeah, you can add strings together, but we're not going to let you subtract them. That's just how they made it. Okay, now here might be one of the trickiest things about strings if you're not used to it. What happens when we add the 12 string with the 12 string? Yeah, we got 12, 12. Because since it's a string, even though when we look at it, we see numbers, Ruby does not treat it as a number. It treats it just as a series of characters, just like a word. Just this word happens to have numbers in it as its characters rather than letters.
And it would do the same thing if you have 12 under the quotes?
If I put 12 plus 12 under the quotes, you mean a new line here?
No. I'm saying like if you remove the quotes on the end of 12, the first 12 and the beginning.
Like that?
Yeah.
That's going to be like that. That's one long string. Yep. So it would be incorrect to say that a string is like a word, because it doesn't have to just be alphabet letters, right? It could be alphanumeric characters. It doesn't have to make sense, right? That's not a word in any language, but it counts. It's a string. Ruby doesn't care whether it makes sense. A string is simply a series of characters in a row. And the way we indicate a string in Ruby is by surrounding it with quotation marks. Strings pretty much exist in every programming language that I'm aware of. Any questions about this? Okay. This is a little lighter, right, after all that heavy calculation stuff. But don't worry, we're going to get back to the heavy calculations just momentarily. One more thing I want to demo to you, and this also throws people for a loop when they first see it, is that you could stick variables in the middle of your strings like so. Let me start over here. So I'm going to make a variable called x, and x is going to be a string called Fred. So just like variables could be a nickname for a number, variables can also be a nickname for a string. Now, I can do this, and that looks a little weird. Let me show it to you, and then we'll digest it. So there's this very interesting syntax here with the pound sign and curly braces. Now, when you put that pound sign and curly braces within a string, you're basically telling Ruby that anything that you find within this curly braces, don't treat it as the actual string, as the actual characters. Treat it as code. And since in my code I have a variable called x, Ruby is basically sticking in my variable in there. And since when I say the variable, remember a variable is simply a nickname for something. So when I say x, that's a nickname for the string Fred. Ruby is essentially inserting the string Fred right there. So when we print that, we see hello Fred in the terminal. Does that make, yeah. Yeah.
Out of curiosity, so I mean, I know like with Python and those, you have different variables you have to put right next to the print statement that you have out. Now, does the variable have to be near it, or let's say if you have a bunch of code and it's at the top of the code itself, in between it? So like
as long as this variable is declared somewhere above in your code, it does not have to be near it. Ruby will know what you're talking about. Yeah. Okay, questions about this? Does this make sense? Is it straightforward? I don't know. I think it's tricky. I think it's confusing. This process of sort of inserting a variable or some like code inside your string, there's a fancy word for it. It's called interpolation. And this actually brings us to that one subtle difference between a string that is surrounded by double quotes versus a string that is surrounded by single quotes. When you're using a string surrounded by single quotes, you are unable to do interpolation. This little thing here, this little trick of inserting some Ruby into the middle of your string, only works with a string that is surrounded with double quotes. So that's why in all my examples going forward, just to make it so I could do interpolation, I'm always going to be using examples with strings that have double quotation marks. Just to show you what would happen, if I used single quotation marks here, then Ruby would print that literally. Ruby only treats that little pound sign curly brace thing as code as if the string that it's within is a double quotation mark kind of string. That is the only difference between strings with single quotes versus double quotes, but it's a significant difference because interpolation is something you often do. In fact, we're about to do it in an exercise. Let me just show this in one more example. I'm going to make x be 100. What is going to happen? So before, x referred was a nickname for a string called Fred. But now, x is a nickname for a number. It's the number 100. What happens when I run this code? Yeah?
I think as long as you have puts, then it'll react to the class that you have access. So instead of it being text and string, it's like an integer in this case. So I think it'll plug it in properly.
Yeah, so Shane is right, it plugs it in properly. But this is weird, right? X here is actually a raw number, right? But however, when you do interpolate a number into a string, basically Ruby just sort of like treats it as a string as well, just meshes it with your string. So the result to the terminal is that it prints hello 100. You sure you got this? You sure you got this? Any questions? Okay, we're going to pair up for the next exercise. Sort of mixes everything we've done together. I assume you're all familiar with the famous song 100 Bottles of Beer on the Wall. So I'm going to slack you the lyrics to that in the general channel, just in case you're not familiar with the exact lyrics of the song. And you're going to pair up. I know you paired up before. If everyone could just sort of shift around one so you're pairing with someone else this time than you paired with before. You want to write a program that prints out the entire lyrics of 100 bottles of beer on the wall. However, don't type it all out. You want to use a loop to help you out here. Does that make sense? So you're basically using a loop to print out the entire lyrics of 100 bottles of beer on the wall. So pair up with someone else. So I guess if everyone pairs like that. So Sam, you pair with Joseph. And Cassie and Cassandra are together. And then pretty much. It's really interesting to see a lot of different people's approaches. I feel like everyone got the main thing, and then people are just sort of tweaking the ending. The ending is certainly the trickiest part. So there's no right way to do this. Who wants to walk me through sort of their approach? Anyone?
Well, first you want to test out, get the first lyric
Okay.
of the song.
So I'm going to copy and paste
Yeah.
that. I'll use puts so we don't get those quotation marks. Okay, 99 bottles of beer on the wall. Okay, so here, this is the part, these numbers are the part that we will replace with variables, right? And we'll do some of that interpolation. So our starting beer number, our bottle, I guess bottles would probably be a good name for a variable. We're going to start with 99 bottles. So we can replace, using interpolation, we can insert that variable name here. Now here it becomes one less, right? Right now if I print this out, it's still the same thing. The idea here is that we want a loop that constantly, right, decreases the bottle by 1 until we get to 0. So we can do a loop. So how many times are we doing this loop for? 99 sounds good. Now right now if I print this out, it prints out the lyrics 99 times, but it's always 99 and 98, right? The whole idea is that we want to decrease bottles at some point. I'm going to do a little nasty trick right here. I don't know if I saw anyone do this, but I'm gonna split up my strings into 2 different put statements. And at this point, I'm going to say bottles equals bottles minus 1. And then I think that gets me all the way there. Again, there's no right or wrong way to do this, but it seems like this is basically the lyrics. This gets me all the way down to take one down, pass it around, 0 bottles of beer on the wall. I saw some of you got fancy because you didn't like the fact that it said 1 bottles of beer on the wall. So some of you had if statements to say if there is 1 bottle, then you should singularize it. In terms of the very last set of lyrics, personally, I would just do it at the end after the loop. So so that's a solution. Any questions about this? Yeah, but there's no, again, I saw various, variants of that.
Yeah, but we overcomplicated it. At break, can you tell us why ours didn't work?
Do you want me to,
Can we save this, and when we have a break, can you tell us why ours didn't work?
do you want to Slack yours to me? Yeah, I could pull it up. I'll Slack out this version. Again,
It's so bothersome.
this is not a better version than anything that any of you submitted. This is just a way to do it. So here's another way to do it, which definitely looks complicated.
Severely complicated, that's why we're asking you to look at it.
Okay, so
It works until like the last 2.
well, let's see what happens when you run it. So,
Do you see how it does 1 bottle twice?
the rest of the way it's good though.
Oh, no, it's not. It's just double up. Yeah, it's fine all the way up
And just until the bottom.
until the last line.
It doubles it instead of goes to else.
Okay, so X is 99, Y is 98. So you're starting with 99 bottles of beer, and then Y refers to 98. I saw other people also take this approach. And then you subtract 1 from X and 1 from Y. So the idea here is you wanted it to,
Until it hit 1.
this is for 1?
Yeah,
Okay.
because the words.
So the problem is that you, I think, forgot the double equals. So remember when you're doing an if statement, you want to use that double equals.
Oh,
It looks like that.
Oh my gosh.
Yeah, that's a gotcha. So it won't get, Ruby won't give you an error when you use the single equals. That's a tricky error because Ruby will not give you an error when you use single equals. But remember, single equals is for when you're creating variables.
Okay.
And a double equals is for when you're saying if this equals that. Cool. Any questions about this? Okay, ready for the next? Okay, the next concept. The next concept unlocks our programs to make them actually usable, meaning you can actually have your friends and family try them out. Now, they may not want to try them out, but at least they could. So I'm going to start a brand new program here. Okay. We're going to say, hello there. What is your name? So this, as we know, will simply print a string. But what if we actually want the user to type in their name, right? So some interactivity between the user and the program. So to do that, we say gets.chomp, which is like, what? What? That's random. That's not what you were expecting. And we'll explain why it is that way in a second. But so I'm going to run this. It says, hello there, what is your name? And I will type in my name. And that's the end of the program. So again, just because you could give it to your friends and family to use doesn't mean that they'll want to use it. Now, when you actually type in gets.chomp, you can actually take that result of what they type in and make a variable that is a nickname for whatever they type in. So I'm going to make a variable called name and set it to be gets.chomp. So I'm going to run this again. You're not going to really see a difference yet. What is your name? J. Now in this version, the string J, because whatever you type in is a string, the string J actually now has the name variable as a nickname for it. So what that means is that in the next line, I could say this. Your name is, and then use interpolation, name that way. So let's run this again. Hello there, what is your name? I'll say Jay, and then the program says your name is Jay. What a lovely name. So it actually used what the user typed in back in the program. So again, on line 2, as soon as you say gets.chomp, remember how whenever you set a variable, whatever happens to the right of the equal sign happens first? Ruby processes that first. That comes into action over here. When you say name equals gets.chomp, first Ruby processes the gets.chomp, meaning it actually gives the user the opportunity to type in something. And only then does it take that result, that resulting string, and assign that to the variable name on the left-hand side of the equal sign. Once you have that variable, in this case called name, you can use that for the duration of your program. So we use it, again, in line 3. We interpolate it into the string on line 3. Does that make any sense? Or do you have any questions about that? Yeah?
Aside from how gets.chomp becomes the variable that you would put after the puts function, but we're going to take that later, I assume.
Meaning why it's gets.chomp?
Yeah, like how does the input automatically become gets.chomp?
So so as soon as your code says gets.chomp, as soon as Ruby processes that, it immediately gives the user the opportunity to type in something. So, I mean, if I just said gets.chomp alone, it would stop, the program stops for a moment, and allows me to type in something. What I'm doing on line 2 is I'm grabbing the thing they typed in and sort of referencing that information using a variable. In this case, I called it name because I'm expecting them to type in a name. So that would be sort of just a descriptive variable name. Did that answer your question, Shane?
Yeah.
Any other questions about this? Yeah.
So can you single out keywords get chump.
What kind of keywords
So
do you
like-
mean?
Like, say if you want to make like an if statement, like if they said something, if they said hi back.
Yeah. So we're gonna do, so we're gonna see shortly how we can use if statements in conjunction with the user typed in. So if the user typed in this, respond this way. If the user typed in the other way, respond that way. We'll be able to do that. Okay, before we do that, let me just show you one more example. This is a slightly, it's just one, it's the same thing we've been doing, just one layer more complex. So here I'm going to just copy and paste this all in. Let's predict, what will happen when we run this program? It's not that complicated.
What's your name?
So what's step by step, what's going to happen? So we run the program, then what?
It's going to get your first name.
So it's going to ask the user for the first name.
Then it's going to ask your middle name.
Yeah.
Then it's going to ask your last name.
Yeah. And then,
Prints out your first, middle, and last.
yeah, awesome. So let's run this. Okay, who wants to volunteer their first name? Who wants to someone else volunteer their middle name? Yeah? Who wants to volunteer a middle name?
Thomas.
Thomas? Who wants to volunteer a last name? I'll do mine. So your full name is Cassie Thomas Wengrow. I would love to meet Cassie Thomas Wengrow. Does this make sense? Here, we asked the user for 3 different inputs at 3 different times, and each time we stored it in a different variable. So we took their first thing they typed in, stored it in a variable called first name. We take the second thing they typed in, store it in a variable called middle name. And we take the third thing they typed in, store it in a variable called last name. We then use those 3 variables by interpolating them into that final string, so we present them with their full name.
So just out of curiosity, the variable that you're getting, is it treating it either as a string or is it treating it as a number? So like let's say for instance you want to grab 2 numbers from them and you want to add them and bring them.
Yeah, great question. We'll get to that in 1 second. Yeah, Joseph, you had a question?
Yeah, why do we have to put the underscore like between middle name?
Oh, yeah, good question. So I didn't really discuss this, but the common convention in Ruby is that if you do have a variable name that really consists of more than 1 word, the common convention is to put an underscore to make it more readable. I didn't have to.
And it obviously recognizes it.
Yeah, as long as you're consistent, yeah. But if I decided to leave out the underscore here, then I would have to leave it out there. But basically, underscore is a valid character for a variable name, and Ruby people tend to put that in to make a 2-word variable more readable. I couldn't put in a space, because every variable name has to be one long structure. Yeah, other questions? Okay. Now, Chris asked about using if statements in conjunction with variables. So I'm actually going to throw this exercise at you before demonstrating it. We'll see how that goes. I'm going to Slack this to you, and then I'll explain it. And you'll do this not paired. You'll do it individually. And you can just Slack me your result when you're done. So I Slacked it in general. Create a program in which the user is first asked for their name. Or I guess, yeah. Basically, they're asked for their name. After the user enters their name, the computer should print cool unless their name is QWERTY. In which case, the computer should print really? Question mark. So basically, it's a simple program. They ask for their name. As long as their name is not QWERTY, say cool. If their name is QWERTY, then you should question them. Then Slack that to me. Take a quick look at this example. So first it says something like, please enter your name. And then we'll say name equals gets.chomp so that the name is now stored that string is now stored in the variable called name. We say if name is QWERTY, then we say really. Else, if the name is anything other than QWERTY, we say cool. So let's try that out. So to test this out properly, we have to test both with QWERTY and without QWERTY. So first I'm going to say my name, and then I'm going to run it again. And I will say QWERTY. And I get really. No offense if you or loved one's name is QWERTY. But any questions about this? Okay. So Kale had a really good question about numbers. So let's start a new program here. And I will say, please enter a number. And I will say, gets.chump, so they can enter something. And whatever they enter, that is going to be stored in a variable called number. The question is the number that I have, is that a number or a string? So one way we could find out is we can try to, remember how we, well, let me show you this. Remember how we did 12 plus 12 like that, ended up being 12, 12 instead of adding the numbers together? So let's see what happens if we add that 12 string, for example, plus the number. So please enter a number. I will say 66. And we get 1266. So this reveals to us that whatever the user types in the terminal as their input for the gets.chomp, even if they type in characters that are numerical, Ruby treats it as a string. So that's a really, really gotcha type of thing that could easily happen to you, where you expect the user to type in a number and you could start adding it to other things only to find that the calculations are not correct because what they entered is considered a string, even if they enter numerical characters. Now, what if we wanted to make a simple program that did some math with user inputted numbers? How do we deal with that? So the short answer is that we can convert user input, even though it starts out as a string, we can convert it into a number. And let me show you how to do that. To do so, we will add something to the end of this gets.chomp that looks a little weird, but it is .to_i. And I'm really not yet, at least, delving into the details of what chomp is and what these periods are, but let's just accept at this point that when you say gets.chomp, whatever the user enters is a string. When you say gets.chomp.2i, which stands, by the way, for to integer, that will convert the user input into a number. So now, let's see what happens when we try this program again. So now I'm going to enter 66. What do you think is going to happen? So now the program actually gives us an error because it's saying there's an error on line 5 saying this weird message that says no implicit conversion of fixed number to string, which is basically Ruby complaining, saying, you know what? This number is a real number. This is a string. I do not have the ability to mesh together a string and a number. Now, if we, let's say, added a number, a real number, let's say 1, plus that number, and we try this again. So if I enter 66, the result will be 67, because Ruby could successfully add a number to this, which is now a real number. And now it does the real math. It takes the number that the user entered and actually treats it as a number and adds 1 to it, giving it a bigger number. So if I wanted a program that said, please enter a number, and I'll double it. So we could do this. We can say, have the user enter a number, gets that chomp.2i, treats it as a number, and then print out number times 2. So here it says, please enter a number, and I'll double it. So if I type in 10, then Ruby prints out 20. It doubled my number. So this is the concept of converting a string into a number, which becomes really important if you're getting user input and you want to do math with it. Any questions about this? Does this make any sense? We've never seen conversion of one type of data into another type of data. So this is taking a string and converting it into a number. Any questions about this?
And when you're converting it to an integer, does it matter if it's a float or anything else?
If they're entering decimal points, yes, then it could come into play, yeah. But for now, we'll just keep it simple. Just deal with whole numbers. Okay. Here's an exercise for you. I'm putting it on general. And it goes as follows. Create a program that asks a user to enter 2 numbers. So think of this as the computer will do it one at a time. Maybe the computer will say, please enter a number. The user will enter a number. Then the computer will say, please enter another number. And the user will enter a number. And then the computer presents you, the user, with the sum of those 2 numbers that the user entered. Does that make sense? And you can Slack that to me. Okay, let's run this program, or look at this program quickly. So we're asking the user to enter 2 numbers, right? So please enter 1 number, and we'll store gets.chomp.2i in a variable. I'll just call it number 1. Then we'll say, please enter another number, and we will store that second number as gets.chomp2i in a variable called number 2, and then we will print out number 1 plus number 2. So enter 1 number, we'll enter 4. 4, 7 is 11. Any questions about this? One thing to watch out for, I saw some people puts equals number 1 plus number 2, but that's not correct. You simply want to print out the result of number 1 plus number 2. Any questions about this? Okay, so let's take a break. We'll meet up at 8:30, and we're going to build a game. It's not going to be super fun, but it's going to be it's a game at least. So like I said, we'll be creating a game. However, we're going to be building it up slowly through a series of exercises. And admittedly, it is not the most awesome game in the world, but it's like the second most awesome game in the world, which is the guess the number game. So if, say I'm thinking of a number between 1 and 100, and you have to guess which number I'm thinking of, and I'll tell you whether it's higher or lower until you guess that number. You familiar with that game? So I'm thinking of a number between 1 and 100. Guess what it is? Somebody.
10.
Higher.
20.
Higher.
50.
Lower.
40.
Higher. Higher than 40. Huh?
42.
Higher.
48.
Lower.
45.
Lower.
I see what you're doing.
44.
44. So that's the game that we're going to be creating, except that the computer is going to think of a number, and the user has to guess what it is, and the computer will tell you whether it's higher or lower. Does that make sense? But we're not building it up right now in one fell swoop. So we're breaking this down into simple problems, but in this case, I'm actually going to feed you the simple problems one at a time until we build up this game. So I'm going to Slack the first exercise to you on general. Now, in this first version, the answer is always going to be 33, which makes the game ever so slightly less fun. But the number will always be 33. And in this version, the user only has one guess. Okay, this is a very simple version of this program. So the way it works in this first round is that the program asks the user to guess a number between 1 and 100. If the user guesses 33, the computer says you won. If the number is less than 33, the computer says too low, or you could say guess higher, whichever one you want. If the number is greater than 33, the computer should say too high. And you just have one guess, and the answer is always 33. So that's this first version of the program. So Slack that to me when you're done, please. So the question on the floor is, can we create a terrible version of the guess the number game where the answer is 33 and you only have one guess? So I think the answer is yes, we can do this. So I'm going to create a variable that is going to store, well, sorry, we don't have to do that just yet. Puts, please guess a number between 1 and 100. And the user will make a guess. So I'm going to make a variable called guess. And say guess equals guess.chomp.2i. Did anyone, curious to know what variable names others chose for this instead of guess? Or if you think it's worth sharing. No? Nothing?
Incredibly bland, just number_1.
Number, okay. Okay. Here I'm calling it guess because to me that represents whatever the user will be entering. Again, I could call it Fred. But again, to make the intent of my code clearer, I'm going to start in this course to be using more appropriate variable names. Okay, so if the guess is 33, then say you won. Else if the guess is greater than 33, then say too high. Else, now here I can go two ways. I can just say else, because by definition, the third choice is it's either, if it's not 33, and not greater than 33. But I like being explicit. So I'll say else if guess is less than 33, say too low. And then we'll run this. Let's see if it works. So if I'll say 50, it says too high. I'll run it again. I'll say 10, it says too low. I'll run it again. I'll say 33, it says you won. And again, your versions may have been ever so slightly different than this, but this is the general approach that most of you took. Is that this like triple if statement kind of thing? Any questions about this? Yeah?
And why do we have, can you just explain again why we have to have 2 equal marks?
Yeah, so, yeah, great question. So when I check if something is equal to something, then the appropriate thing to say is 2 equal marks. The single equals marks is only used in one and only one circumstance, and that's when I'm setting a variable. And that's just the way Ruby is. So here I'm actually setting a variable, so it makes sense to use a single equal sign. But here when I say if guess is 33, I'm not actually setting a variable, I'm just checking for equality. I'm just checking to see, is their guess 33? So that's when you use double equals. Again, this is pretty arbitrary, right? I mean, that's just the way they made it. It would have been much easier if it was just like always single equals or something like that. But does that make sense, Joseph?
Yes.
So the answer basically is yes, it's an arbitrary decision on the part of the creators of this language. Any other questions about this? Okay, so let's modify our program. So through each exercise we do, we're going to make our game ever so slightly better. Slacking to the next set of instructions on general. So the next set of instructions is to modify your program so that the user has 8 tries to guess the right number. And use a loop in order to accomplish this. And then if the user doesn't guess the correct answer in 8 tries, the computer says you lose in a very rude way. You don't have to make it rude. So I want to modify this program so that the user has 8 tries instead of just 1. So the main thing here is simply to wrap this code in a loop. And I guess it's up to us. I think different people did different things. But I'm going to basically do this whole process of guessing this process of the user inputting a number and us telling the user if it's too high or too low. We're going to repeat that whole process 8 times. Let's see what happens when we run it like that. So please guess a number between 1 and 100. I'm going to guess a bunch of numbers. And as you see, as Evelyn pointed out, the program's not over even if I guess 33 before my turns are up. Any questions about this? Yeah.
I was wondering, why do your quotation marks not show up?
Because I'm using puts instead of p.
Yeah,
And that's the difference between puts and p. P shows it literally, and puts is a prettier way of printing strings. Any other questions about this? Perhaps to make it a little more user-friendly, I might, at the first step of this loop, might say, please enter a number. Because perhaps it's not so intuitive every time the program stops that you're entering a number. Yeah, Sam.
Oh, I just put that with higher
Oh, you said please try again in here?
Yeah.
Got it. Okay. Yeah, that's another way to deal with that. Any other questions about this? Okay. The next, so let me show you one way to get around the problem of the fact that right now the computer keeps on having you guess even once you've guessed the correct answer, which is sort of silly. So I'm introducing a new concept related to loops that we've never encountered before, and that is a special trick that lets you exit a loop before it's done. Okay, there's a special keyword for that in Ruby called break. So you see how I put break there on line 9? So what that does, I should test it out before I tell you what it does. I'm going to guess 33 on my first guess, and it says you won in the program, and the program ends. So what break does is says that if you're in the middle of a loop, even if you still have a few more loops to go, break will exit the loop. It will skip, it will take Ruby beyond the last end of the loop and move on. So this is a new concept, but very appropriate for our situation where we don't want the loop to keep on going once the user guessed the correct answer.
Yeah, well, break would be a variable, right?
Break is not a variable. Break is simply a keyword. Think of it like P is a keyword that prints something. Break is a keyword that exits a loop.
Tag.
What's that?
We call that like tags, right?
Tags? I call it a keyword. That's the same name. Yeah. In Ruby, it's called a keyword. Basically, anything that's not a variable or like a number or a string is a keyword. Like if is a keyword, do is a keyword, end is a keyword. So break is a special keyword that exits the current loop that you're in. So that's sort of a new mind-bendy thing. Any questions about that? Okay, the next thing I want to show you is how, I guess right now the most lame part of this game is the fact that it's always 33. So let's randomize a new number. So to randomize a number in Ruby, the simple way to do it Let me show you in a new tab. So if you say round 100, or in this case I say p round 100, so I could print it to the terminal. Let's do that again. Round 100 actually doesn't do exactly what you think it does. It gives you a random number between 0 and 99 inclusive. So if I keep on running this, you'll see it's a random number, right? What if I wanted a number between 1 and 100? What would I do? What's that? Well, 101 would get me between 0 and 100. What if I want between 1 and 100?
0.100.
That gets me between 0 and 100. So the trick here is I'm just going to add 1. So since rand 100 gives me somewhere between 0 and 99, I'll just add 1 to whatever that number is. So I'll end up with a number that's between 1 and 100. Does that make any sense? So using this little snippet of code, we can enhance our game by making it so that the number is random every time. However, if I start sticking that rand thing everywhere it says 33, it's not going to work because every time I mention it, it's going to keep on randomizing a new number. So what I want to do here, so this is something very, you want to watch this carefully, is I am going to be moving up this variable, or this 33, I'm going to consolidate it into a single variable. So I'm going to make a variable called correct answer. For now, I'm going to make it 33. Everywhere in my code where it says 33, I'm going to change it to correct answer, which doesn't change my program at all functionally, because every time I mention the variable correct answer, that is simply a nickname for 33. But now that I've done that, I can now change the 33 to be some random number between 1 and 100. So if you follow the code carefully, on line 3, the computer generates a randomized correct answer. That will always remain the correct answer for the duration of this program. But then the computer initiates this loop 8 times where it allows the user to guess for the correct answer 8 times, and it lets the user know whether it's too high or low. So trying this out, I'm going to enter a number. At this point, I have no idea what the number is. So I'm going to start with 50. It's too high. I'm going to guess 25, which is too high. I'm going to guess 12, which is too high. 7 is too high. 4 is too high. 3. Answer was 3. And you would all get different results when you run this. So the ability to randomize our number greatly enhances this program. Although it's still debatable whether it's actually fun. But it's fun for my kids. So. Any questions? Yeah.
Yeah, so I was running that and I accidentally put it in the letter in and it just said too high or too low. Is there a way to make sure it's very
Oh, so if you typed in, yeah, great question. So Sam is asking, so I'm going to run this program again. Please enter a number. I'm going to say hello because I don't listen to directions. Too low. Do you want to know, first of all, it's really interesting. You want to know why it's saying too low. Like, why that? Shouldn't it be like an error or like, I don't know what? So interestingly enough, and I'll show this here as well. This is a weird thing. If you convert a string into a number by simply attaching that .2i at the end, it's 0. It's just always 0. So no matter what I put in here, now I don't know why it's 0, honestly, because why? Why? That's sort of arbitrary. Like if I were Ruby, if I were designing a language, I'd be like, I refuse. I'm giving you an error. I refuse to convert that string into a number because that doesn't make any sense. okay, forget the language design decisions, but the reason it is saying too low is because when you do type in hello as the user, and in the program it says gets.chomp.2i, it's converting that into 0. So one way you might want to get around it is you can check to see if the number that was entered is 0, and then you can give them another try. So I am just thinking right now if I'm going to demo that right now. I will not demo that right now because it involves one concept that I didn't introduce yet. So I don't want to confuse things. But that's a good question. Any other questions? Yeah. Oh, no. Any other questions? OK, so the next thing I'd like to do, I'm debating whether to just show it or give it to you as an exercise. I'm going to give it as an exercise. And that is another improvement to this program, which is make it so that if the user wins, the program doesn't just say you won. It says you won, but it also tells you how many tries it took you. So you won, you got it in 5 tries. That's an exercise. So right now, the thing we're trying to do is be able to sort of give the user the score, right? And say, oh, congratulations, you won. It took you, say, 6 tries. So this is a sort of a thing you get used to the more you do these types of things, is that any time you want to think about keeping track of some number, especially if you're like keeping track of some number that you're constantly adding. So here, like every time the user does another try, we're increasing their number of tries by 1. Very, very often, the place to start is to create some sort of variable that starts at 0. So whenever you're dealing with adding numbers to a variable, think about starting a variable that starts at 0. Again, to a human, that's not the intuitive way we think about things. If I say, what score, how many tries did that person take, right? The answer is never 0, right? The person, I guess the person took 0 tries before they started. But as humans, we usually think about starting at 1, right? Numbers start at 1. But when dealing with computer programs, very often it makes sense to start at 0. So I'm going to, before the user before the loop begins and before the user actually begins typing in numbers, I'm going to create a variable that keeps track of their number of guesses. So I'll call it, I don't know, number of guesses. And before they begin, I'm going to start this variable out at 0, because they have not made any guesses yet. Then, as they make a guess, so every time the loop goes around and the user enters a number here on line 9, where we say guess equals gets.chomp.2i, every time the user does that, that means that the user is making another guess. So I'm going to increase the number of guesses by 1. So which I do by saying number of guesses equals number of guesses plus 1. Does this make sense so far? I'm not fully done yet, but I'm starting out number of guesses at 0. Every time the user makes a guess, I'm increasing that number by 1. Now, I will utilize that variable. I may as well interpolate it into the string on line 13. So I'll say puts u1, it took you, and I'll interpolate with that hash curly braces thing, number of guesses. Let's see if that works. So guess the number between 1 and 100. Ooh, 500 is way too high. I meant to say 50. Too low. too high, too high, too low, too low. Okay, so I guessed the number 61, and here it says it took me 7 guesses. Is that correct? 1, 2, 3, 4, 5, 6, 7. Indeed, it did take me 7 guesses. So I think that's all I need. Does that make sense? Any questions about that?
Did you slack that to the group?
Yes. Let me save this and slack it to general. I mean, this program is becoming more and more involved, right? If I asked you, hey, make the guessing game between 1 and 100, it's difficult to just come up with all of this. But as you build it up piece by piece, it's still not easy, but it is somewhat easier. So again, it's hard to teach the official way of how to reason about any problem. But as a general hint, if you're ever trying to keep track of any number that you're adding over time, always think if perhaps you can start out with a variable that starts out at 0 and work your way from there. That sometimes is the way to help you. Sometimes it's not, but it's a place to start at. Similarly, if you're thinking about multiplying, keeping track of a variable that you're multiplying a bunch of numbers to, then it makes sense to start that variable out at 1, because then as you multiply numbers to it, 1 is a good starting point. But for adding numbers together, 0 is a great starting point. Any questions about this? Okay, now coming back to the thing that I at first gave you as an exercise and then decided to take out. We wanted to say you lose, or something to that effect, if someone actually guessed all 8 times and did not guess it, right? So to do that actually becomes much easier now that we've been keeping track of their number of guesses, because basically someone loses if they get through the entire loop 8 times, right? If someone, well, there's 2 ways to get out of this loop. One is if they win, in which case we use the break keyword to get out of the loop. The other way to get out of the loop is by actually going through the loop all 8 times. And if you did go through the loop all 8 times, that means that you lost. Unless you got it in the last try, but that means you used the break keyword anyway. So what I would say is here at the end, I would say if number of guesses is greater than 8, if by the time you got to the end of the loop, your number of guesses is something like 9 or more, well, it's never going to be more. It's always going to be, let's say, 9. Then we'll say you lose. Well, it depends how rude you want to get. So I'll run this, and I'll guess 1 a whole bunch of times. Whoops. So that actually didn't work. Why not? If number of guesses.
Because you're increasing the number within the.
Yeah. So if I get there, so really if it is 8, right?
Yes. So
not if it's greater than 8, or if it's greater than 7. But now I'm actually stuck again, because if I get it on the last try, here, let's see this. It's actually trickier than I thought it would be. So here I do lose. However, here we're still, so if you do guess it on your 8th try, the problem is it will actually, the number of guesses will be 8, but you'll have gotten it on your 8th try, and it will still say you lose. So my solution actually isn't so good. I have another trick up my sleeve, but not presenting this in the most clear fashion because I wasn't expecting this to go haywire, but so I do not yet have a clear solution here. Does that make sense? I have some other solutions in my head, or at least one other, but I'll hear from you guys first if you have another solution.
Well, couldn't you do a wrap it around the entire if statement inside the while loop?
So put this where?
So if you put it after the number of guesses and do
Here?
Yeah, because it will be greater than 8 times because your number of guesses will go up.
Mm-hmm.
Right? By the time you're going through with the loop, right?
Yeah. But you still might guess it right over here. So
yeah, but if you guess it there, it's never. Let's say you break right at. Oh yeah.
it will say you lose a little prematurely.
Mm-hmm.
Yeah.
Just make it an else statement.
So walk me through it.
So just make it else
So where should I put, what line should I be on?
19.
19? So here,
Yeah.
else? Is that what you mean?
Yeah.
Okay, when does this else ever get triggered?
If it's if what's it called? Number of guesses is like equal to 9 or greater than 8.
So hold on one second. So am I using this somewhere?
No.
Not using it at all?
It's similar. You just change if to else.
Okay, but you want me to put it here?
Yeah.
So I don't think this else is ever going to get triggered, at least as is, because either the guess is the correct answer, or it's higher than the correct answer, or lower than the correct answer.
Or you can put it by, so you just move it all the way up at that point.
So where should I move it?
Line 11. And just change the if to else if.
Here?
Yeah.
And what's the if?
If number of guesses equals 9, probably.
If number of guesses equals 9?
Yeah.
But I don't know if we'll ever
Then
equal.
just increase the amount of time.
Okay, so you're saying increase the 9. Okay. And then, so if I hit 9 times, then say you lose and then break.
Yeah. Well, actually, we wouldn't need to break, right?
Yeah, I guess so.
Or,
Yeah.
yeah.
Let's try that version. Yeah, so that seems to work. Is there another approach? Yeah, nice job, Chris. Do other people have a potential approach here? So another possibility that I'm thinking of is we can make a new variable, like did user win? And we'll start it out as, let's say, no, string. And then when the user wins, we can say did user win is now yes. And when we get to the end of this whole structure, when we get out of the loop, I could say if did user win is no, then say you lose. Does that make sense? Let's try that before we see if it makes sense. So that seems to work also. So again, there's no correct answer, but this is a particularly thorny problem. Like you think just to say you lose after all the tries is like simple, but it's actually a little tricky.
False in a way too.
What's that?
You use like a true false.
Yeah, I just didn't teach true false yet. Yeah. Any questions about this? I'll select this version out too, just so it's out there. And there's probably 5 other ways to deal with the you lose problem. Okay, any other questions about this? Okay, moving on to the next concept. Just kidding. We'll end a minute early. Have a good night, everyone. See you tomorrow.